Welcome to another fun-filled edition of Comet Algebra. This video is for Algebra 1, Chapter 6, Section 7, Graphing Linear Inequalities. So let's go through the steps you will need to follow to graph these linear inequalities. Inequalities meaning it has a greater than or less than sign in it. Now, step number 1 says solve the equation for y. That should sound sort of familiar. We've been doing that all chapter. But I would like to remind you of something. When you are solving an inequality, it is the same as an equal sign except for one thing. If you are multiplying or dividing both sides by a negative, the inequality needs to reverse or flip. So please keep that in mind. I mean, look at all the stars here. You can tell how important this is. So watch that negative sign only if you're multiplying or dividing by negative. Adding and subtracting a negative is no big deal. Step 2 then, we need to graph this linear equation. Now remember how when you were graphing on a number line, an open circle on a number meant that that number was not included in the answer. So maybe we're going this way. On another problem, when you used a closed circle and it was all filled in, that means the 3 was included in the answer. So in the way that we had open and closed circles on a number line, when we're graphing on the two-dimensional plane, we have a dotted line. I think your book might call it a dashed line. That is used for when you have less than and greater than. And this dotted line is indicating that the points on the line are not included. They are not part of the solution. In the same way, the open circle indicated that that number wasn't part of the solution, but the solution started right super close to it. When your inequality is less than or equal, or you have a greater than or equal, that's when you use a solid line in the graph to show that the points on that line are indeed a part of the solution. So just watch your dotted line and solid lines. Then we need to shade a region of the graph. If we're talking y being greater than or equal, we shade above the line. We will be shading below the line for less than and less than and equal to. And believe it or not, your calculator will help you with this shading. Now, the answer is not just 1xy. The answer is every point that lines in this shaded area. So there's infinite answers to these inequalities. We just need to mark the region of the graph where all those answers would lie. So if you're going to use your graphing calculator, this is the name of the app you need to turn on. It's under the apps menu. Scroll down to in equals and just hit enter twice to turn it on. And then you'll have to see that on the y equals, and every calculator is a little different. So see me in class if you can't quite figure out how to make the greater than and less than appear. And if not, it's really not that bad. We can figure out whether to shade above or below the line. So let's look at our first example here. We're asked to graph 6x minus 2y is greater than or equal to negative 10. So step 1, we need to solve for y. So we're going to start by subtracting a 6x from both sides. I'm going to move over here. So now I have negative 2y is greater than or equal to negative 6x minus 10. Almost have it solved for y. Now we're multiplying by a negative 2, so I need to divide every term by negative 2. And right here is where we notice that we are dividing by a negative. Therefore, this sign, this inequality, must flip. So let's rewrite this now. We are solved for y. The inequality flips to less than or equal to. You do keep that equal to part. And now we just do the math here, 3x plus 5. So now we have to graph this, and we are going to be shading, since y is less than or equal to, we are going to have, let's just make some notes to ourselves. We're going to have a solid line because of this equal to part. And we are going to shade below the line because y is less than this line. So let's go to the plus 5. That's our y-intercept. 1, 2, 3, 4, 5, and put an x. The slope is 3. So it's going to be uphill. It's a very steep positive slope. So I'm going to even run off the graph here a little bit. Up 3 and over 1. So let's just count this backwards a little bit. Down 3 and over 1 is right here. Down 3 and over 1. I'm just counting a positive slope backwards. We need to be able to do that. And now, once again, I'm going to attempt to draw this line in connecting these points, but that is just not easy to do with this pen. So we know it's a solid line, so I'm going to keep my pen on the paper. All right, that's not bad. Not fabulous, but... And so I used a solid line because the line is part of the solution, and now shading below it means all this part is where the answers lie. That means this is an answer, here's an answer, here's an answer, here's an answer. Anything that lies in this shaded area, there's countless answers. So either shade above or below the line. This next example, we're given a solution and we're asked if it is, or I should say we're asked, is this point, is 1, 1 a solution of this inequality? Well, we could plug in the values for x and y and see if it makes this inequality true. And if it's true, we'll say yes, it's in the solution area. And if it makes it false, then it's no, it's not in the solution area. So just plug them in, basically. -8 times 1 is -8, plus 2 times 1 is 2. Is that greater than a -4? So -8 plus 2 is -6. Is this true? Well, no, -6 is not greater than -4. It's less than that. So since this is not true, that means that this negative or positive 1, 1 is not a solution of this. So we would say no, not a solution. So just plug it in and see if it makes the inequality true. All right, that's it. Now you have all the knowledge you need for section 6.7. So have fun with math.